Hope you guys can all see the screen. Okay, so number one, we're going to be spending time just rewriting our terms, get each term ready for power rule. But you can tell that most of the terms are not quite ready for power rule. So we want to make sure we expand out each of these terms. If we see any variable in the denominator, we want to make sure we resolve that. If we see any radicals, we want to convert that to rational exponents. And so we gotta make sure we can full and expand this out correctly, right? We gotta write this out twice, expand this out first before we distribute the 7x cubed. Okay, so x minus 1 times x minus 1 gives me x squared minus 2x plus 1. Now I'm ready to distribute that 7x cubed through. And along the way, I'm just cleaning up any denominator coefficient or denominator constant. I can just pull that out in front as a coefficient in front. No calculus yet. We're just trying to get every term ready for power rule. This becomes x to the 4/5. This becomes x to the 7/2 and brought up to the top. So x to the negative 7/2. So we're not quite ready for power rule because this is still needs to be resolved. But once we distribute that 7x cubed, we should be ready to go. Okay, so this is the cleanup that's required to get every term up to the starting line so that we can apply power rule. Any questions up to this point?
It says dy
Mhm.
over dx. What does that mean?
That just means find derivative.
Oh, okay.
Yeah. So you can see notations like y prime, f prime of x, dy dx. They all mean the same thing. Just find the derivative. So this means find the derivative of y with respect to x.
And you'll use one of the rules to find it over.
For this one, it'll just be power rule. Yeah. Okay. So now we can apply power rule for each term.
Thank you so much. Have a great day.
We can bring the exponent down in front, subtract 1 from the exponent for each of the terms. 2 pi x becomes 2 pi. 5e to the 4th does not become 20e to the 3rd because e is just a number. So this will all go to 0. Okay. And then we go through power rule for each of the terms here. Okay, so 35x to the 4th. 14 times 4 is 56x cubed, 21x squared. We bring down the 2x, and 2 and 3 gives me 6. So I just multiply that as part of my coefficient. 2 pi x becomes 2 pi.
Security alarm. Everything is clear. We are all clear. Thank you so much.
2 pi x becomes 2 pi. 5e to the 4th becomes 0. 2x to the 4/5 becomes 8/5 x to the negative 1/5. Bring down the negative 7/2. We get negative 7/3 x to the negative 9/2. And then no negative exponents and answers. So we have our derivative. We just have to push these variables back down to the denominator to make these positive exponents. Any questions? Morning. Got handouts you can pick up. Okay, so number two, we have a fraction, but notice there's only one term in the denominator. I'm going to specify on the quiz not to use quotient rule. I want you to use power rule for this. Okay, so there's only one term. If there were more than one term below, then we're kind of stuck using quotient rule. But since there's only one term, we can split each of these up into individual fractions, clean them up individually, and then do power rule, because we can split this messy expression up into three smaller problems, and then each can be its own independent thing.
Before you like do anything, should you just split everything up?
Yeah. We'll split everything up. So I'm going to distribute the 4x through. I'm going to rewrite the radical as rational exponents. I'm going to begin splitting them up into individual fractions. So as I distribute that 4x through, this becomes 4. This is x to the first power, x to the 1/2. 1 plus 1/2 is 3/2. Distribute the 4x through, I get 12x squared. Distribute the 4x through, I get, sorry, this should be a minus 4x. Let me check. And then my denominator is 5x to the 9/2. Careful with this. A lot of students want to say x to the 1/9 or x to the 2/9, but this is x to the 9/2. And then we can also split up into individual fractions. So I want us to understand that when we do this, we're basically taking a complicated looking problem and splitting them up into three smaller, more reasonable, easier to access problems. Because now we can work on each part.
So much for your cooperation.
Right? Any questions up to this point? No calculus yet. We are still trying to work towards getting to the point where we can do power rule. We're still not there yet, but we're getting closer. Morning. We're doing a worksheet that you can pick up there. Okay, so we know that even though these are individual problems, we can only do power rule if the variable is up in the numerator. So we still have to bring the variables up to the top. So to do that, we have to subtract the exponents. So 3/2 minus 9/2 is negative 6/2. 2 minus 9/2, same thing as 4/2 minus 9/2. And this is 2/2 minus 9/2, which is negative 7/2. So as we subtract exponents, I'm also going to push the coefficients out in front, and I'm trying to get each term nice and clean, ready for power rule. And this is what we have. So the 4/5 comes out. 3/2 minus 9/2 is negative 6/2. 4/2 minus 9/2 is negative 5/2. And then 2/2 minus 9/2 is negative 7/2. So now this is nice and clean. Every term is ready for power rule. Our next step would be power rule. But understand that at this stage, we haven't done any calculus yet. Even though we've subtracted exponents and brought them up, that's just because we need those conditions to do power rule. Any questions up to this point? Okay. How to get the fraction part? Let's see. Negative 6/2. So I subtracted these exponents. So 3/2 minus 3/2 minus 9/2 will be negative 6/2. Yeah. And then 4/2 minus 9/2 will be negative 5/2. And then 2/2 minus 9/2 is negative 7. I think it's the hardest part. The hardest part is just get to this part, because if this were given to you as the starting problem, you can just go through power rule, right? But to get to doing the algebra to get to the point where we can do power rule, where we can do the calculus is the hard part.
Can you simplify?
Oh, sorry, this is a minus sign here. Yes, you said you can. Yes, yeah. Yeah, that'll make it a lot cleaner. Okay, so now we can do power rule. Bring the -3 down, we get -12/5 x to the -4. If you want to convert that to -3, it'll be a little bit cleaner without all these fractions here. But we get the same thing, right? -12/5 x to the -4. We bring down the -5/2. So -5/2 times 12/5 gives us -6 x to the -7/2. We subtract 1 from the exponent. Bring the -7/2 down. Subtract 1 from the exponent. So -7/2 minus 2/2 is -9/2. And now it's just a matter of cleaning up. -3 times 4/5 is -12/5. X to the -4, we bring that back down to the denominator. Here, this cleans up to be -6. X to the -7/2, we bring the x back down to the denominator. And here we get -14/5 and bring the x back down to the denominator, x to the 9/2. Okay, and dy dx is just another notation to find the derivative. Right, so we know that these denominator variables are out of place. So we have to merge these together. So to do that, we have to subtract exponents to bring them together. So -3/2 minus 9/2 will be -6/2, which is -3. And then this is 4/2 minus 9/2, -5/2.
How do you know that's 4/2?
Because I got to do common denominator, because I can't quite subtract 2/1 minus 9/2. I got to match common denominator, so it's going to be 4/2 minus 9/2. It's -5/2. All right, any questions with number 2? Okay, number 3, we have a function x over x squared minus 2. Find f prime. Then write the equation of the line tangent to the function at x equals 1 in point slope form. So, or let's find f prime first. So f prime, we can't just do power rule and just do numerator denominator and make it 1/2x. We have to go through the full quotient rule, right? This is numerator denominator. So The reason that we didn't do quotient rule for number 2 is because there's only one term below. We can actually avoid quotient rule. But here, there's more than one term in the denominator. We can't quite split up into individual fractions as easily. So we're forced into quotient rule.
We can get the formulas for the rules in the test or not.
No, you're gonna have to memorize it. Yeah, same on the AP exam. So anything that you're gonna have to know for the AP exam, we have to kind of practice memorizing them. Okay, so f prime. I'll do it from scratch here. So let's build out f prime first. So we know we have to go through quotient rule. Okay, f prime g minus f g prime all over g squared. Sorry. The numerator is my f, denominator is my g. So let's go down the line here. What's f prime? What's the derivative of x? Just what? G function, no changes. Back to f, no changes. G prime becomes what? 2x. All over denominator square. Sometimes students forget about this portion. This is also part of my derivative. This is also part of quotient rule. So what's g squared? Minus 2 quantity squared. Okay. Simplify fully. So we're going to make sure we expand this out. We cannot cancel the x squared minus 2. We understand that, right? We can't cancel this out. So we just have to spend the time to expand that out and see where that takes us. Okay, these are not the same things. We cannot reduce that either. It kind of has to stay in that form. Even though they look similar, the signs are not the same. We can't. Negative 3x. Which part? This right here? These are being multiplied. So this becomes minus 2x squared. Okay, so are we good with f prime? So it says write the equation of the line tangent. So anytime we want to create a tangent line equation, we have to gather two sets of information. We need order pair and we need slope. So order pair comes from the original function and slope comes from the derivative. So we can plug 1 into the function to get my y value. Then I can plug 1 into the derivative to get my slope. Once I have my order pair and my slope, I can do point slope. So here's me plugging 1 into the function to get my y value. So 1 over 1 minus 2 is 1 over negative 1, which is negative 1. That's my order pair, 1 comma negative 1. I can plug 1 into the derivative. Here's my derivative. Plug 1 into the derivative to get my slope. I get negative 1 minus 2. Negative 3 over 1 is negative 3. My order pair, my slope, point slope form. There's my equation. The point is sort of given. Sometimes it will be given to you fully, sometimes it's not. Here, this problem only gives you the x value. So you have to actually find the y value on your own. But if the full order pair was given to you, then you would only need to find the slope.
All right, so Ashley, what if you can't? Like, if you can simplify that more, then you just simplify it and then you plug in one of that equation.
But we could also find the slope without simplifying. We could plug it into this form. We would just still get the same.
Oh,
slope.
you would?
Yes.
Okay.
Yeah. The simplifying just makes it a little cleaner to look at. And also I asked you to simplify. That's fine.
Yeah, okay.
But yeah, we'll get the same slope plugging in here, here, here. Yeah, they should all give us the same value. Back page whenever you're ready. Okay, number 4. This is a particle moves along the x-axis. X of t equals tq minus 6t squared minus 15t plus 1. So this is telling us where the object is located at any moment in time along the x-axis. And we're looking at t greater than or equal to 0. Okay, include units with your answer. Find velocity and acceleration functions. So we can just go ahead and go through power rule, right? Find v of t, find a of t. Any questions with part A, building out 2 derivatives, velocity and acceleration? Velocity is just the first derivative of position, and acceleration is the second derivative of position. Okay, part B, what is a velocity at 1 second? So we have our velocity function. We can plug 1 into t and find the velocity. Include units with our answer. What is our unit going to be for velocity? Meters per minute, yeah. And what's acceleration's unit going to be? Meters per minute squared, yeah. Make sure that you're squaring the minute. Okay, are we okay so far? Part D, find the average velocity of the particle between 1 and 2 seconds. This is the one that gives students the most trouble here. because you see the word velocity, but you're not going to touch velocity. The way we describe average velocity is basically the slope of position. We're only going to use position function, and we're just finding the order pairs of our position functions at 1 second, at 2 seconds, and we're just finding the slope between those 2 points. We do not touch velocity function. If we're asked to find the velocity at a moment in time, then we will use velocity. But if we're asking about velocity over a range of values, then I got a handout there. Then it's just the change in position over change in time. Okay, so we find the position at 2 seconds. We find the position at 1 second, just plugging it into the original function. And then we just do change in position over the change in time. And that is our average velocity.
Oh, so when you get average velocity, it's you just use the position
Function. Right. You can understand why students miss this so much, right? Because students just want to do, oh, velocity. I'll just do v sub 2 minus v sub 1 or some variation of velocity, but we cannot touch velocity, not for average velocity. Now put a star next to that. So as long as you know that is going to give students trouble. Okay, part E. When is particle at rest? What does that mean? Not acceleration. Velocity is at 0. Yeah. Velocity zero means the object is not moving. And so if it's not moving, then it's at rest. So we set velocity equal to 0. Factor, solve for t. Now there's a restriction with t. They tell us at the beginning of the problem that t is greater than or equal to 0. So -1 would not be part of our interval. Oh, I started here and I took out GCF of 3.
So you don't use the position.
No, not when we're talking about rest. Yeah. Okay, any questions up to part E? Part F, find the average acceleration of the particle from 1 to 3. Now that we've done part D, does that help you create the formula for part F? Yeah. Average acceleration is the slope of velocity. So v of 3 minus v of 1 divided by 3 minus 1. Because average acceleration is defined as the change in velocity over the change in time. It's frustrating for students because they're like, why can't we just use the function that the name is called after? But it's because we have calculus that we're actually able to have a specific formula for velocity and acceleration. Before, it wouldn't be an issue with Algebra 2 because, or pre-calculus, because we didn't have a velocity function, so we're forced to just use the position or just use the velocity for average acceleration. So we find the velocity at 1 second, we find the velocity at 3 seconds, they happen to be the same value, so that ends up zeroing out, but our units is still in terms of acceleration, 0 meters per minute squared. No calculator, yeah. So the numbers will be easier to work with. Okay, are we good up to part F? Next up, when is the particle moving right? When is the particle moving left? When does the particle change direction? This is where we got to create a sign line, right? So we'll create a velocity sign line. We have information from when particle is at rest. So this is going to go onto our number line, our velocity sign line. So 5 will go on it, -1 will not go on it, but we're also going to include 0 because 0 is the starting point for our problem. So our number line will just include 0 and 5.
Do you normally include 0 on these?
Only if it ends up being a velocity equal to 0. If it shows up when you factor velocity out and solve for t, or it is given in the problem that it's a restriction, then you would include it. Here, it's showing up not because velocity is 0 at 0, but because it's a restriction.
Oh, because it can't go less.
It can't go less than 0. So that's a starting point for our
So just don't test below it or not?
We don't test below it. Now, if the problem does not have any restrictions, then we'll have to test negative numbers as well. Okay, so are we good with creating that sign line from with 0 and 5? Next up, we have to figure out what the signs are in each subinterval. So I'm going to find test numbers. So I'm going to choose numbers in between each subinterval. As small as possible, we like to use small numbers. It's easier to plug in. Where do I plug in the 1 and 6? Into the velocity. Yeah. Okay, so I'm going to plug 1 into the velocity. You can plug it into here. I like to plug it into the factored form. The factored form gives us the sign a lot faster, less calculations involved. So what happens when I plug 1 in for t? 1 minus 5 is positive or negative? Negative, okay. And then 1 plus 1 is positive. Negative times positive is negative. So I know that between at first interval, between 0 and 5 seconds, this particle is moving to the left. If I plug 6 into the velocity function, again, there's all these different variations of velocity, but you want to find the factored form. That's the easiest one to plug into. It's not wrong if you do the other velocities. It's just more calculations. 6 minus 5 is positive. 6 plus 1 is positive. 2 positives makes positive, yeah. So looking at this number line, we should be able to kind of visualize what's happening with this object, right? When the timer starts, the object is moving to the left for 5 seconds. And then at 5 seconds, it's going to stop, turn around, and move to the right, and continue moving to the right indefinitely. So now that we have our number line, we can answer our questions because we just read our answer off of our number line. Particle moves right from 5 to infinity. And remember, you're not going to use these test numbers anymore. These test numbers are just to get the signs. You're not going to include them in your statements.
Interruption. If you're a substitute and it's a badge number 6, then see this badge number 6. I need you to report back to the main office with the badge. Substitute, if you picked up badge number 6, I need you to bring it back to the main office. Thank you.
Particle change, our reasoning, we have to give justification. Our reasoning for particle moving right is because V of t is positive, V of t is greater than 0. Particle changes direction at t equals 5 since V of t changes sign. There's no sign change, there's no direction change. Yeah. So I'm going to say give justification. So justification means you have to include a because statement. Or, yeah, I said since, but because. Okay, part H, what is the displacement of the particle from 1 to 4 seconds? Displacement is just what's the distance between where you started and where you ended? So displacement is just change in position. We don't do anything with time, just change in position. So it kind of looks like average velocity. It's just the numerator of average velocity. It's just change in position. So it's just going to be x of 4 minus x of 1. So we find our position at 4. We find our position at 1. I know these numbers are large, but we're just plugging them into our position function, and we're just doing our final position minus initial position. So wherever you end up, subtract wherever you started. That's your displacement. So we get negative 72 meters. What that tells us is that between 1 and 4 seconds, this particle is going to end up 72 meters to the left of where it started. So start at negative 19, and it's going to go all the way left to negative 91. So in that span of time, it's covered 72 meters going left. Okay, are we good with this, please? Distance, I haven't quite gone over it in class. I'll do that today. But distance is basically saying how many. So imagine you're walking along the x-axis, okay, and it's asking basically how many steps have you taken between 3 to 6 seconds. Doesn't matter which direction you're going in. You're just counting your steps. So we know that at 3 seconds, I can plug 3 in to get my location. I'm standing all the way over here at negative 71 on the x-axis. So imagine every step is every tick mark on the x-axis. However, at 5 seconds, there's a change in direction. So we have to figure out where I stop. So negative 71 at 5 seconds, I'm over here at negative 99. And then at 6 seconds, I'm all the way back at negative 89. So imagine you're starting here, you're walking here, and then you're stopping, turning around and walking back. And you're just counting your steps. How many steps have you taken from here to here and then from here to here? And just count, just total them up, keeping a counter. So from negative 71 to negative 99, you've taken 28 steps. From negative 99 to negative 89, you've taken 10 steps. So in all, you've taken 38 steps. So however many steps you take is the total distance. And then the last few here, is the speed increasing or decreasing? Increasing, decreasing speed, we have to compare the signs between velocity and acceleration. If velocity and acceleration show the same signs, then speed is increasing. But if velocity and acceleration are showing different signs, then velocity is decreasing. Sorry, then speed is decreasing. So in this case, velocity at 1 is negative 24. Acceleration at 1 is negative 6. We just plug into our velocity acceleration functions. They're both showing negative, so speed is increasing. And K is a little bit trickier because the wording looks almost the same. It's just saying, is velocity increasing or decreasing? And so the two mistakes students make is they think that this is a speed increasing problem, and so they compare signs, so we don't do that. Or they look at that word velocity and they feel like they can just look at the signs of velocity, and that's also not the case. Because this is increasing or decreasing velocity. This is asking about the rate of change of velocity. This is asking if acceleration is positive or negative. Acceleration at 3 seconds is positive, so therefore the velocity is increasing since acceleration is greater than 0. So that's a tricky part. So this is the one that students miss the most, as well as the average velocity. Those are the two typical ones that people trickier. And this is what your quiz will look like. It'll just be, first page will just be power rule, quotient rule, writing a tangent line equation, and the second page will just be a particle motion.
Will the second page be just like one equation like this one was? Wait.
So like, not multiple, just like one.
Yeah, just one stem and then everything built off of that. What do you mean?
Wait, will we be on this side?
Yes, be front and back. You have to make this. There's another worksheet in there, and then I'll do that worksheet Thursday morning.